right on time, I'm going to hand it over to Max for our second talk. And thank you, everyone. Again, we will have plenty of time for questions now for Max talk, as well as for Mario, as well as a wider Ask Me Anything, if you will, in about 45 minutes to 50 minutes, depending on how quickly Max gets through his material. So looking forward to your questions, and now enjoy Max talk.
Hopefully it won't be that long. You folks can see my screen. Thumbs up. Yeah, great. So quite a wordy title, but I thought it might sort of capture a few things that I've been working on recently, and also kind of capture the crowd, because I think there's a few provocative things in there. But this idea of infrastructure and product, you don't often see, I don't think, together in the same sentence on a program of work. When we think about product thinking, we tend to think about, you know, a website or a service that an end customer is getting, and so an infrastructure is usually sort of buried right down there in the bottom. So hopefully I can take on a little bit of a journey into some of the things that I've been thinking about and working on. So going back to when we think of a platform and platform as a service, it can spark, depending on where you are on your journey, it'll spark lots of different things. But Heroku is one of those products that sort of comes to front of mind for me when platform as a service gets mentioned. So it's one of those most easy to use things for a developer. I'm sure a lot of people on the call have used it, if not heard it. And it was this idea that you could just, any developer could just write a piece of code, pay some money to Heroku, run a command, and then suddenly their website or whatever their application is will be deployed. So, you know, the feedback loop here is fast, and it's also pretty easy to connect the money trail. So, you know, you just pay Heroku and you get a dyno, which is sort of this worker node that's invisible and in the cloud, and you run a command, and hopefully the bucks start rolling in. If we were to look at that from a sort of a platform, the most basic platform, and in this diagram, these orange boxes here are, you can think of them as sort of actors in the system, or activities that go on, or even chunks of value that are happening. So Heroku is a principal in this and provides some sort of value to a developer or a number of developers. And I mean, before I go any further, I was just going to say platform is one of those contentious words. It's heavily overloaded in the marketplace, and it probably means different things to everybody. And you know, happy to have some questions about, or some disagreements as to what my definition is. But for the purpose of this talk, you know, in this particular scenario, Heroku is a platform. Hope that's kind of clear. But also the applications that the developers are building on top of Heroku could be considered as a platform, depending on what the customer above that is doing with it. So for the purposes of this talk, this is what I'm talking about. And, you know, like I said, Heroku is one of the early contenders in that space. But when you think about it in terms of who's providing who value, this idea of producers and consumers, which is also often associated with API building, can be used here as well. So like I said, Heroku produces some sort of value proposition. Developers then go and consume that, and they use that, and they weave things together, and then they produce a different set of value for customers. And so you start to see this kind of platform forming. So I think in this diagram here, I'm just trying to sort of show the way that these layers sort of connect to each other in terms of who's providing who what. When we go back to thinking about the sort of the value chain and where the money's coming from, you know, the customer's obviously going to pay something to the developer, you hope. And you sort of hope that costs, or rather the payment that you receive is covering the costs of what you're developing. But also you hope it's covering the costs of the services from Heroku you're getting as well. So you kind of, like, if you're in this scenario, you're probably going to do your accounting pretty quickly. I mean, there's not too many variables here. So this is what I kind of see as the financial mechanics of whether you're spending the right amount on your platform. And it's at this point that I think a lot of people suddenly go, I'm spending too much. You know, they turn that dyno dial up and suddenly they get this huge bill through and they think, oh God, you know, I need to rethink what I'm doing here. Or the other problem that I think people find with Heroku is that in this particular case, is that it just offers a slightly limited set of possibilities what you can do. So one of those two things happens: either I'm spending too much, or I feel too constrained, I can't do what I want to do. And so your typical developer or team of developers will be like, oh, I've got AWS, or I've got Google, or I've got Ali Cloud or something. I'll just spin up a VM and I'll be able to get something else working. And quite often people will say, oh, it would be cheaper if we do this in public cloud, which I think some of the basis of this talk is like, it should be, or it could be, if you put the right process around it. Quite often it ends up slightly different and ends up costing a lot more potentially. But I still think it is the right thing to do. And a lot of the customers that I'm helping, public cloud is the right way to go for them. We still use Heroku in certain situations as well, but nothing against that. But what usually happens is you move your workload to a VM, let's say it's an EC2 instance or a container or something like that, and suddenly you need some logging. Marion talked earlier about CloudTrail as a big kind of source of logging for AWS people. And you're probably going to want to plug in some monitoring and alerting. Suddenly you need to scale or auto scale, so you have to sort of configure that. Persistence, you probably want a database. So it builds and builds and builds. You want a Kafka thing, you sort of get the idea. The problem is whatever gets offered by a public cloud usually gets used, because developers are the interested people, and they go and grab as much as they can. But these are some of the sort of the most basic, I guess, commodities of the cloud that you might start thinking about. But we all know it's a lot more complex than that, if anybody's actually looked at public cloud. And this basic set of commodities that I just mentioned before is impossible to see amongst this, basically. And on the left here, we have Google's offering, and on the right here, we have AWS's offering. And I couldn't even fit it all on the screen. And again, I haven't put some of the other cloud providers on here as well. But it's obviously not just databases and logging and Kafka. And it begs the question, what does this mean for a full stack dev now? I mean, that term is just unfathomable in this world. So it got complex. So going back to our diagram, potentially we've got multiple dev teams. I'm sure people on the call, I'm sure very few people are just working in a scenario where there's just a single dev team. Although obviously that does exist, especially in startup land. But for the purposes of what I'm trying to explain here is that as the dev teams scale and as the offering scales, it becomes a little bit more confusing as to how to calculate whether the customer, whether the value that the customer is getting is worth the money that you're paying, and whether you're making the most use out of all of these options. I don't think it's long in this scenario before these developer teams that I've pictured here start solving some of the same problems in an inefficient way. So you can imagine that they all want to go really fast. They all start just kind of pulling some things together and logging, and maybe they're doing this as code using Terraform or something, cloud formation or something like that. And you can just imagine, I'm sure everybody's seen some problems like that. Or, maybe you are super disciplined, and maybe one of these teams says, oh, we'll be the Kubernetes people, we'll manage the Kubernetes cluster for you. But even so, you'll start to see some commonalities and things like that where you'll need some good discipline and practice. And I think, looking back at the previous screen, there's also a lot of areas to build expertise in now. So it's really hard for developers on a developer team to just suddenly become experts in all of these different areas. I mean, never mind what they need to do, but maybe they don't want to do that. So anyway, there's lots of opportunity for duplication here. And, that's sort of where the crux of my, the problem statement is here. And this is where I've been focusing a lot of my time recently. So I'm going to introduce you to sort of 3 different implementation attempts that I've been a part of over these years, and to sort of talk you through some client stories. And I'm just going to describe them as smaller, older, and younger. So I didn't know it at the time, but the sort of experiences that I've had, I mean, I think one of these goes back about 6 years ago, but just sort of pondering and thinking about the way that I was going to talk about some of these things, I realized that actually I have some quite interesting, diverse examples of platform engineering here. So starting with the smaller one, it's just 10 developers. You could argue that the developers were mostly full stack in a sense that they knew a little bit of front end, they could code some Java services, and they were, pretty comfortable navigating around AWS. And we were definitely going for this sort of, the dev team owns their system in production. So this sort of no ops mentality that some people strongly agree with or disagree with. But again, I think some of this will resonate. I would say that some of their challenges were around, or some of our challenges were around needing to learn a lot of stuff to go live. That was the main things, that we didn't want to do a bad job of things like operations. So, okay, should we get PagerDuty in? Should we, how do we do good alerting? So we needed to get that stuff right. We were also taking on new tech like Datadog and Kubernetes, and this was before EKS. So this was with COPS, and we used Auth0s and IDP. So lots and lots of new pieces that we needed to become experts in very quickly. The nice thing was, though, is that everybody wanted to contribute and everyone had kind of an open mind and an appetite. But that's smaller. Looking at the platform sort of picture of that, if you like, it was really simple. I mean, there were just two parties involved. There's AWS that we were consuming, and then there was a whole bunch of tech that the joint dev team were looking at. And you can argue there were kind of other parties here. So like I mentioned, some of those third-party tools, if I was drawing this in more detail, I'd probably draw some of those as extra people. But for now, we'll just look at that. I think the main thing to talk about is that the infrastructure and application dev work was all happening under the same team. And it's worth having a think about, I mean, this might look good to some people, but it's worth pondering, what could possibly go wrong, which I'll talk about a little bit later. Moving on to the older client. So this was a 120-year-old bank, had over 100 developers divided up into a whole bunch of teams. And sort of as traditional organizations tend to go, or at least ones who have been around for a long time, it's very tempting to build teams as you scale around technology function, rather than what we refer to today as kind of product-centric teams or agile teams. Their challenge was that they just had sort of a pitch from the COO, I think CIO, to move from on-premise cloud to public cloud. They also had some of those classic enterprise organization patterns, like if you've heard of the frozen middle, where you've got sort of a management layer in the middle that's built up that is a little bit resistant to change. They did have a courageous executive who had, brought Thoughtworks in and had sort of tried to organize into an agile culture. So that was good, but with this frozen middle, that was tough. And, the 120-year-old bank, you think it's a financial institution, they're going to be heavily regulated, but the time that they've been around means that over time, they've got a lot of learned helplessness and some broken communication paths and things like that. So it was a tough environment to be in. And from a platform perspective, they had teams for everything. And like I said, none of these were sort of formed around business products or services. They were formed around technologies. So there was a lot of back and forth between all of these teams. And if you're familiar with Conway's law, that sort of really was quite prevalent here. So, around security ops, production ops, network ops, they had a team for everything. Now, when you think about trying to navigate the concept to cash, or that sort of where the customer is paying for the service, and then how much is being spent on each individual layer around here, becomes very confusing, compared to our Heroku model. And so this was a tricky environment to be in. And then finally, the younger client, they were still big, actually. This is the most recent one that I've worked with. They were a mixture of developers. You had a mixture of people who knew their one thing, which was PHP in this case. But you had others who were sort of willing to push themselves either side. They also needed to scale, but they also had quite a big monolith as well that they were trying to decompose, as well as sort of migrate to the cloud. But like I said, the important thing that made it a bit easier is that there's a lot of appetite to change. They were open to new ideas. So looking at their platform, and I'll summarize this in a minute, you don't need to take notes. But a much simpler case. And they'd actually started with a platform engineering team. So they'd already acknowledged that actually going to the cloud, there's a lot of complexity there. They've got a lot of teams that are going to need to be nurtured through this process. And they put a team on it, which I think is a really important thing. It says a lot to the rest of the organization. So there was some way actually towards seeing developers as customers, which is for my 15 years have always been my customers. And I sort of put SRE knee platops there because they're not quite SRE in a Google sense right now, but they were moving away from that traditional ops mentality and looking much more at sort of measurement and stability and resilience. So to summarize, we have all of our three distinct, sort of some similarities in there, but I think there's quite a nice diversity in there. And I wanted to talk about some of the early indicators where each of these organizations on their journey to sort of getting better use out of the cloud started to diminish. So with the smaller, I think we started to see, even though we were in this one sort of nice team, everybody was kind of willing to flex in different directions, you still saw people's natural direction to go more into Java than infrastructure, or more into infrastructure than Java. And if you start trying to encourage people down a path where they're not that keen on going, or they don't feel like that's where they want to spend their time, you're not going to get the best results either. But we're lucky enough on the team, we did have some people that were infrastructure savvy people and understood kind of what good monitoring, alerting, and some of those ops aspects were. On the older client, I think we had far too high expectations that we were creating a self-service product, and we had an expectation that developers, if they just coded a bit of Chef, which was a Ruby-based kind of infrastructure tooling that's not so popular at the moment anymore, but back then we just thought, well, let's just give them, if you just write a little bit of Ruby code, and this is talking to a Java developer, then you'll be able to control your own pathway to production. And it didn't go down very well. And we built this sort of very cool cloud, and it was very sort of automated, but it required developers to know it, to learn, and actually want to learn a little bit of Chef and Ruby and understand a little bit about the infrastructure domain. And it was broken. We did have some success with it, but it was really slow going. And reflecting back on it, we now have this developer experience concept in the industry. So yeah, we just got to the just talking about some of the early indicators, and there was a lot of back and forth chatter still, even though there was this good kind of understanding of what the developers as the customer. It was still a very high chattiness between developer teams and the platform engineering team, and that surmounted in terms of you're starting to see a lot of cross backlog dependencies on our developer team backlog. So they had a lot of needs from the platform engineering team. And so you start to sort of have that contention and that bottleneck. So you sort of ask the question, well, what were we measuring? I'm an ops person. I always think about things to measure, but I also think we can get a little bit obsessed about this. I certainly can. For those of you that are in software delivery and haven't read this book, I urge you to read it. It's extremely consumable. And I won't go into it too much because we lost a few minutes just then, but out comes the sort of this idea of the 4 key metrics, and Thoughtworks has written about it in the radar, so you can go read about it in detail there. But these things are actually quite difficult to measure, and especially if you're just starting out, investing time and energy in measuring these things is not actually something I would recommend doing. Except if you do it in a very lightweight, easy way. Like, don't go away for sort of 4 weeks and start building tooling and monitoring systems to measure all of this before you've even developed a product and tested it in your market, for instance. Slightly different to what Marion was saying. I do believe in the terms of IAM policies. I do think that is something where you should sit down and just spend, even if it's a couple of weeks, planning out at least the first iteration of that. But this stuff is hard to measure. And so it'd be nicer if there was a way to get some early measures, some early indicators that are a little bit cheaper than that. Looking at the smaller team, like I said, we were small, measuring stuff was expensive. So we didn't really measure anything. We were keen on learning, keen on sort of making sure that we weren't failing. But in terms of the 4 key metrics and things like that, we didn't measure. We had a sense that things weren't going right, like I mentioned in the previous couple of slides. And in the older one, this was about 6 years ago now. So we were so happy that this bank was moving to the cloud, we actually forgot about that developer experience piece. And sort of measuring that, we were just measuring about how much faster we could spin up servers, regardless of whether developers actually started using those servers, which is, a huge blind spot. But with the younger team, this sort of newer team that I've worked on, I guess I was a little bit more savvy. Obviously, I've got a few more scars to show. And so we did start measuring some early things. And I looked at this cross-backlog dependency aspect and had some good success with it. So that's what I want to share with you. And actually, the reason I was so honed in on this is because I think amongst certain circles and conversations I've had over the years, people say, oh, a DevOps team is an anti-pattern. You can't have this team of experts that sit in the middle of kind of development and production. And so when I joined this team, this platform engineering team that was already there, I thought, you know, the thing that was keeping me up at night was how can I prevent that? How can I prevent me getting laughed at by my friends in the pub? And so another talk that I saw actually from James Lewis, who's a colleague at Thoughtworks, and actually he was piggybacking on some work that another colleague has done, Evan Botcher, on actually tracking cross-backlog dependencies. And they did an experiment at an Australian telco, this was around 2012 now, I think, where they actually started to measure of the stories that a team can do and solve within the team versus those that they need to go to another team to, you know, have a story on their backlog. The difference was about a factor of 12, which is quite phenomenal. And I've used this slide a few times with organizations because it just solidifies how important it is to try and accomplish the work by getting the right people in the team. Now, you could argue that having infrastructure people in the dev team is a solution, and we can talk about that in the Q&A. I'm not going to go into that just now. But it's, you know, it's evident that cross-backlog dependencies are difficult. Now, I'm not proposing a utopia where no one ever needs to have other teams work together. That's not what I'm suggesting. What I'm saying is that this is something to measure and to try and minimize if you can. So what I started to do is look at Jira, and we were building a cloud platform from scratch. And looking in Jira, I could see a bunch of tickets starting to get raised on one of our customer teams. And of course, in the beginning, we didn't even really have a cluster. So some of these early tickets were like, we need a cluster, we need something to deploy a Docker container to. So team one had about 8 tickets initially that needed some help from platform engineering. They needed some of this stuff to be available. So in the beginning, you know, quite a few tickets. And over time, those dependencies became less and less. So this was something really cheap. I think we just did a label that said need platform engineering in Jira. And then in the platform engineering team, we were able to kind of search and filter and get ahead of this. As well as that, we had a meeting every week just to talk, you know, what are the up and coming needs that you have, sort of provide them that service. Looking at team 2, you know, there's some interesting data on this. I think the first thing is to notice is that actually when we onboarded team 2, they didn't have 8 stories that needed our attention. They had 2. And what does that mean? That means that they were able to piggyback on a lot of the value that we delivered for team 1. This is what I'm calling prod panic. So I think the low fidelity way that we did this, you know, there wasn't a huge application that we'd written to measure all of this. We were just using labels in Jira. I think as this team 2 started getting closer to production, they suddenly thought, oh, we need monitoring, we need alerting, and we need the platform engineering team because they're the experts to come and help us with all of this. As it turned out, we weren't actually needed for a lot of that. So you can see this spike went up and then it went down very quickly, not because we did work, but because we said, hey, you know, you guys can do this yourself. Just have a look at some of the documentation that we've got and some of the tooling. But yeah, the main thing is that team 2 onboarded with 2 stories. Roll on to team 3. This is about a 5-month timeline. I'm not sure whether you can all see the times down there. This is real data from a client. But yeah, when we get to team 3 and team 4 and 5, we actually start to see much fewer stories. And so team 3 went in with 1. When we got to team 4 and 5, they actually delivered to a pre-production environment without any assistance from platform engineering. And what does that mean? Well, it means that the products or the services that the platform engineering team were exposing they were well factored enough such that new teams that had completely different needs were able to utilize those without needing to come to a platform engineering team and say, I need you to go and build me X. So that concept of domain boundaries and loose coupling, again, is another thing that you associate a lot with APIs. And I don't think that's an accident. This is also great. I mean, this actually took us to small-time fame with the executives on the client, because they can really, usually platform engineering and infrastructure people are way down there in terms of what people care about. But with this, it was very easy to articulate in 5 months, just by using some JIRA measurement, the value that they were getting from investing in platform engineering. So going back to the second aspect that we took away from this new team is product uptake. And, you know, I've talked about products in this sense, and I think it's useful to try and describe what I mean by a product. We talked about cloud commodity, which is sort of interchangeable. So if you think about services or a stack of services that you're building, the products that I'm talking about for platform engineering services are things like application deployment, persistence, or databases, log aggregation, alerting, et cetera, et cetera. Now, we started off with some of these. Now, log aggregation, you can argue, should just be a part of other stuff. If you're doing a database, you should have a log system in place. If you're doing app deployment, you should have a log system. But log aggregation is like, you know, if you've got a Sumo Logic or a Datadog or an Elk stack, that's something that we offer people to use with some documentation stuff around it. But like I say, like you can reconfigure these. And if you've done things well, it's just like refactoring an API. I did want to call out to Sam Newman's book, because although it's not about infrastructure, it does talk about how to break up, how to decide what becomes a microservice, and some things around domain-driven design. And the same thing applies here. And some of the paragraphs in there were sort of resonating with me, which is if you don't know where these boundaries exist, just start off with things together, but just be adaptable to shake out the boundaries later. But again, in order to do that, you do have to have a culture of revisiting code and refactoring. Otherwise, it never happens. And we've all had cases of that sort of prototype code that hit production. So just be aware of that. It's context relevant. But back to the younger team, the final client in the case study here. I wanted to track that the products that we were producing were not only just getting used by one team, but were getting used as much as possible. Obviously, there'll always be a team that needs a Kafka queue, a Kafka stream, or an SQS queue, and maybe another team doesn't need it. But for the most part, you hope that you're developing products that are well factored such that they're easy for other teams to uptake. So this is, again, it's not, there's no right version of this, but it's just really useful information to see how things are working, which direction are things trending in. Again, as I said, like some of these on the left-hand side, we've refactored these. These weren't quite the right shape to begin with, but after sort of several teams and iterations, we got into a good spot. Finally, I think one of the final bits of sort of advice, I guess, or takeaways is if you're talking about products now, and hopefully you do take that away with you in an infrastructure context, why wouldn't you have a product owner? And I think some people might argue that you know, your customers are around. Do you need a product owner? You know, happy to talk about that. But I think infrastructure is all code now. You know, there's no reason why we should treat an infrastructure-based team differently to a Java team or a team full of, you know, front-end React developers that are building a new front end. I think I've started to think if I land on a team and I just see a bunch of infrastructure devs, my immediate thing is, okay, who is the project manager or delivery manager? Is there a product representative? Should we have a QA? I mean, QA and infrastructure is, I think, going to be a huge thing coming in soon. So how do we do, I mean, the testing tools have existed for a long time, but how do we really, especially when infrastructure is the foundation of everything that you're doing as a business, getting it right and getting it high quality is more important, if anything, than the other layers in the stack. So I'm changing this in every organization that I go to, and I hope you can take that away as well. So looking back, I think if I was going to pick one or two aspects from each of these. And it's nice to be able to frame all of these in a single view, that in the smaller, very agile, very highly functioning full stack environment, we still went to a separate team for the APIs and a separate team for the infrastructure. And I think thinking about Conway's law and thinking about where you want your interactions between the teams and the interactions in the architecture, even though we were a small team, it was right. It became sensible for us to split to give our application stack the best chance to sort of scale and to onboard more teams. With the older, the 120-year-old bank, it was just a poor developer experience. It was, I just would go back and do things so differently there. And I think this is the forefront of my mind whenever I land in an organization, is how happy are the developers and why are they not happy? And start there. And you can't always appease everybody, but I think it's a really good place to start. Be very user-centric. And on the younger client, we had the product mindset, and we started doing early, albeit sort of a bit hacky. We started to get measures, some indicators of which direction we were going. So wrapping up, to me, I think the items that I've taken away from this, hopefully you can use this checklist on your own teams as well, is, start measuring things. Think about what's important to the organization. Think small, cheap, effective. The 4 key metrics are there. Read the book, absolutely fantastic. But you might not get there immediately, and there might be some trade-offs there to make as well. But certainly have a look into that. If developers, which are users in this context, don't want to use your stuff, you've probably failed. It doesn't matter how good it is. If developers aren't going to use or deploy to your stack, I don't think you can be successful. Loosely coupling infrastructure is definitely hard. You can talk to anybody about doing that. Like we did, this was not easy. We had to have a lot of discipline and rigor on the team, and some good testing, some good software development. But you can usually spot when you're doing it wrong. I would say things start to sort of couple. You start to get issues where you edit one bit of the code and you need to edit a lot more of it. So watch out for your domain boundaries, especially between products, but also between teams and other parts of the architecture. Having a dedicated product owner, technical product owner, hopefully. I mean, I'm playing a technical product owner role. So I've been a developer before, I've been an infrastructure developer. So having somebody who really understands sort of where is cloud moving to, who are my customers? Have I been on that side of the fence before? Do I have empathy with them? It's really important. But the second you have a product team and a product owner, I think it really starts to change the language that you have with the rest of the organization, and it brings people's attention to it as well. I think if you're doing all of this, you're already starting to think in terms of platforms, but think about those layers. Think about how the investment is happening between those things, depending on where you are in the organization. But I think if you're doing all of this, you're halfway there. Thanks very much.